Welcome back. So now we are going to solve one more problem. It's one variation of the prefix sum. So what you have to do in this, you will be given one array, okay, one integer array and one integer k. Okay. So what you have to do, you need to count the number of subarrays. You have to count the number of subarrays whose sum is equal to k. Okay, so subarray, you might be knowing that subarray is a continuous part of the array. So suppose one array is given that is having 1, 2, 3. So if someone is saying can you find out all the subarray, so subarray will be the continuous element. So subarray will be 1, 2, 1, 2, 3, 2 and 2, 3. Okay, these are the subarray. Of course the 3 will be there, but you can't take 1, 3. This is not subarray because it's the skipping element. So continuous subarray, continuous part of the subarray. Okay, so if someone is saying can you count out the number of subarray whose sum is equal to k? Yes, I have got all the subarrays. Now I'll see, okay, this sum is 1, okay, this sum is 3, this sum is 7, this sum is 2, this sum is 5, this sum is 3. If someone is saying can you find out the where some of the elements are equal to 3? Yes, I can find out this one, right? So my answer would be 1, 2 and 3. So you have to return count number, count equal to 2. This is the answer. Got it? So let me repeat again what's the problem. So we are given one array and a target sum k. Our goal is not to find just one subarray but to count all the possible subarray whose sum equal to k. Since subarray must be continuous, so you cannot rearrange the element or we cannot skip the element. Okay, so and the brute force that I talked about, so brute force is nothing but in brute force or in a naive approach, what you are going to do, you have to find out first all the possible subarray, then you have to find out the sum of those subarray, and we have one counter whose sum is equal to k. You have to increment the count. Okay, so for the naive approach, so what is the step? First generate all the subarray, correct? Then calculate the sum, then count it. I mean compare and count, compare with k and count, correct? These are the 3 steps. So generating this subarray is, this is itself a very tedious task. And suppose you are giving 1, 2, 3, so you are going to generate all the subarray 1, 2, then 1, 2, 3, then 2, 3, then 3, right? So if this size is very big, then this is going to take order of n square, and after that I have to do these operations, comparing and calculate the sum, right? So you have to calculate this sum for each this subarray and see if it is matching with the k or not. Okay, so can we solve this problem with some different approach? Yes, of course we can solve this, and the approach that you are going to apply is prefix sum. Okay, so let's do a dry run with the prefix first, and we will observe how this is going to improve the performance. Okay, so you might be surprised. So first let's do this prefix sum approach. Okay, so let me take one example. I'm taking a little bit bigger example so that we can draw multiple cases. 2, 3, 4, 5. Okay, and k I'm looking for 6, correct? So first step is you have to build the prefix array. Okay, so prefix, you know that from 0 to I whatever element is coming, so prefix 0, that is equal to 1. Prefix 1 means 0 to 1, total sum is 3. Now prefix 2 means 0 to 2, 6. Same way prefix 3, that is equal to 0, 1, 2, 3, 6 plus 4, that is 10, right? And same way prefix 4, that is equal to 15, and prefix 5, that is 15 plus 6, that is 21, correct? So my prefix sum array will become 1, 3, 6, 10, 15, 21, correct? This is the first step. We have done this. Okay, and if you remember the formula that we have used in the last video also, if your I equal to 0 means for the first index your sum will become, is not going to change equally. So prefix, this is always a sum correct, right? If I equal to 0. In rest of the cases, what we are going to do in else condition, your sum will become prefix j, means suppose this is a sub array, so this is j, this is I, okay? So prefix j minus prefix I minus 1, so I will be here somewhere, so I will become 0. So in this way we are going to calculate the sum, okay? So remember this formula. Okay, let's do the dry run now. So my array was 1, 2, 3, 4, 5, 6, correct? Now I have to choose the sub array. In sub array there will be two index, I and j. So j always represent the last index of the sub array, remember this, and I is the start one. Till now no doubt. So let's start with j equal to 0. So any index starting with this, so I equal to j equal to 0, I equal to 0, so I to j sum we have to calculate. Sub array will become how much? From I to 0, this is nothing but there is only one element, right? 1. So I equal to 0, so sum equal to simple prefix for as a based on the formula prefix 0, that is 1, correct? Prefix I we are taking, right? If you see here, right? Then we are going to compare. My sum is equal to 1 if my sum equal to 6, because I am looking for 6, right? It's not. Then I am going to increase, I mean we are going to take the next element, okay? So now j equal to 1. So if ending index of the sub array is 1, then it could be start from I equal to 0. So 0 to 1, so my sub array will become how much? 1, 2, right? Then sum will become prefix I equal to 0, right? 1, that is equal to 3. In prefix array, if you see here, this is 3, okay? See here, prefix is 0, 1, 2, 3, 4, 5, right? So 1 equal to 3. Now compare this sum. 3 equal to 6, no, we can't do. Let increment the I now. So if you increment the I, then sub will become 2 only, because this I is gone, right? So now sum will become prefix, since I equal to 1, so it will go in the else condition. So prefix 1 minus prefix 0, correct? I minus 1. So this will become 3 minus 1, that is equal to 2. Still 2 equal to 6, no, I can't do anything. Now let's move to j equal to 2 now. If j equal to 2, remember this is a very important step now. For I equal to 0, so what is my subarray? It will become 1, 2, 3, right? 0, 1, 2. Okay, this is j, this is I. So sum will become, for I equal to 0, the last index, right? Simply. So prefix array of second index, that is nothing but 6. If you see in the prefix array, second index is 6. So 6 equal to 6. This is match. It means you found one array, so you increment the count equal to 1 now. Initially it was 0. Now check I equal to 1. Okay. So what will be your subarray? It will become 2, 3. Correct? Now apply the formula. The sum equal to prefix 2 j, right? J equal to 2 prefix 2 minus prefix I minus 1. So prefix I minus 1 means 0. So that will become 6 minus 1, that is equal to 5. Okay. So someone might ask why we are doing this, why are we subtracting this prefix 0. So remember, for this case, what I need sum? I need sum from I equal to 1 to j equal to 2. So if in a prefix array I need sum between 1 to 2, so I need only this sum. Till here I have sum, right? If somehow I subtract this sum, I'll get the exact sum that I'm looking for. Okay, so this is what we are doing here. I'm just subtracting start of the index, I mean j. Start of the index means I minus 1. Alright, so that's why we're doing this. Okay, so let's compare 5 equal to 6. No, this is still not correct. Now let's do I equal to 2. So in case of I equal to 2, your subarray will become only 3. Then sum equal to prefix sum 2. Okay, means 2 to 3 we are doing now. So prefix sum 2, prefix of j, that is 2 minus prefix of I minus 1. So I equal to 2, so I minus 1 equal to 1. So this is nothing but 6 minus 3, that is equal to 3. And 3 is again equal to 6. No, it's not matching. Okay, I am going to ignore this. Now let's say I is over. Let's j equal to 3 now. So for j equals to 3, let's I 0. So my subarray will become 1, 2, 3, 4. Correct? My subarray will become this one. So sum will become I equal to 0. So simply I'm going to sum of all. So prefix 3, that is equal to 10. Right? I equal to 0 means you are starting from the 0 index. So from 0 to any j, it is already we are calculating in the prefix sum. You don't have to do any formula. So that's why I am taking this one. For I equal to 1 now, my subarray will become what? My subarray will become 2, 3, 4. This will be removed, right? So what will be the sum now? Prefix j minus prefix sum what? I minus 1. So that is nothing but 10 minus 1, that is equal to 9. Correct? So 9 is equal to, here 10 is not equal to 6, right? So I am ignoring this. 9 equal to 6? No. So I am ignoring this again. I equal to 2 now. In this case, my subarray become 3, 4. Correct? So my sum, if I do, so sum equal to prefix j is nothing but 3, so that is 10, minus prefix I minus 1, so prefix 1, so that is nothing but 3, that is 7. Still 7 is not equal to 6, so I am ignoring this. Now coming to I equal to 3, my subarray become 4 now. So sum equal to what? Prefix j means 3, minus prefix I minus 1, that is equal to 2. So this will give you 10 minus 6, that is equal to 4, and 4 is again not equal to 7, so I am ignoring this, correct? Now coming to j equal to 4, subarray become a big number now, right? 1, 2, 3, 4, 5, and sum will become how much, since I equal to 0, right? So simply sum, so that is 15, and 15 is not equal to 6, I am ignoring this. Now I equal to 1, so my subarray will become smaller, so that is 2, 3, 4, 5, so sum will become how much? Again 15 minus 1, that is equal to 14, and 14 is still not equal to 1, so I am ignoring this. Now same way I equal to 2, subarray become 3, 4, 5, right? 2 will be removed. Now sum will become again 15 minus previous 2 sum, so that is equal to 3, so that is become 12, and 12 is not equal to 6, so I am going to ignore this. Now I equal to 3, my subarray will become now 4, 5, so sum will become 15 minus previous to 4 all the sum, so that is nothing but 6, that is coming 9. So your 9 is not equal to 6, so I am going to ignore this also. I equal to 4, so my subarray will left with only one element, that is 5, and sum will become 15 minus all sum before, so that is 10, that is nothing but 5, right? So that is also not equal to 6, I am ignoring this. I5 we can't go because I equal to j now. So now coming to j equal to 5. In this case I am doing for the same thing. You should also do this because this is going to give you intuition why the improvement is needed. And when we do the improvement, you must be knowing, okay, what patterns were repetitive, what need to be rechecked. So that's why I'm doing this all operation. This may be a little bit boring, but you have to understand that. I equal to 0. So my subarray will become whole element, right? 1, 2, 3, 4, 5, 6, and sum equal to become prefix of j. So that is nothing but 21. And 21 is not equal to 6, so I am crossing it. Same way I equal to 1, that is also not going to work. Just see, you have to do this and let me know in the comment if you required. Then I equal to 3, this is also not going to. In I equal to 1, I think it will work, it will come 20, and in case of I equal to 2, this will come 21 minus 3, that is 18, correct? This is also not equal to 6. In case of I equal to 3, subarray will become how much? 4, 5, 6, right? This much. So sum will become 21 minus 6, that is equal to 15. So it is also not going to work. For I equal to 4, the sum will become 5, 6, so that is coming nothing but total sum 21 minus previous to this, so that is 10, that is come to 11. This is also not equal to 6. Now I am going to do I equal to 5. In case of I equal to 5, subarray left with only one element, that is 6, correct? right? So now going to do my sum equal to what? Prefix of j. Okay, prefix of j what? 5, correct? So 5 is nothing but 21 minus 15 previous to all that is coming to 16. So now by this sum equal to 6 in case of I equal to 5 means 5 comma 5, I equal to 5, j also equal to means the last element, that is 6. So our count is going to be increment here, count equal to, earlier it was 1, so now it will become 2, correct? So sub array which sum is coming to 6, that is 1 comma 2 comma 3 and 6 itself. So this is answer. Okay, hope you understand that. So what we're doing here, though we have used prefix sum, but if you see the calculation for each j, I am going to do what? 0 to j, correct? For each j, I is going to move from 0 to j, so it is again order of n square. So nothing much improved, right? So we have to optimize this. So let's think about this. What could be optimized? Because I have to bring this down to order of n only. So what we are doing till now, whenever doing the sum, we are doing for each j prefix j minus prefix I minus 1. Prefix I, correct? And we are checking if this is equal to k or not, right? If this is a mathematics, so let me rearrange this. I can write this prefix of I is equal to prefix of j minus k. I hope you understand this, right? So what we were doing earlier, for each j, I was taking one loop for all I, that is start from prefix I equal to prefix and I'm checking here prefix I equal to prefix j minus k. I mean these things, okay? Okay, so what is the idea behind this? So instead of checking for all I, if we store all the prefix value I have seen so far, okay, so what about the prefix value that were already encountered, just store in one map. Okay, so in order of, let me rewrite this again. For each j, I was doing for each I, if prefix j minus prefix I equal to k or not. Remember, in all the previous steps you have done this. So I'm going to transform this now. For each j, check how many prefix I equal to prefix j minus k is already present. Okay, and we are going to do this using a map. Okay, now in this case we are not going to create the prefix sum explicitly. We are going to create the prefix sum with a running in a runtime. Okay, so whatever sum will become, that will become running preface, right? Okay, so let me do the same operation with this approach for the same array. And k I am looking here 6, correct? So sum equal to, let initialize some variable, sum equal to 0, count that is equals to 0, and map for the first element I am going to add the index 1. So we are inserting 0 with frequency 1 to handle the subarrays which are starting from the 0 index. Okay. So now let's start with the iteration. So iteration when index equal to 0. So what is the value of 0 here? Value equal to 1, right? So my sum will become 0 plus 1, that is 1, right? So I'm going to check now if my sum minus k equal to 0 or not. Okay, sum minus k equal to what? 1 minus 6, that equal to minus 5. So we are going to check, we are going to actually update the map now. So my map will become now 0 with 1 frequency and 1 with 1 frequency, right? Now going to index 1. So index 1 is having value 2, correct? So sum will become previous sum 1 plus 2, that is equal to 3. Now let's check sum minus k. 3 minus 6 equal to minus 3. No, you also don't know, right? So now this sum is already encountered, so I'm going to add the frequency. My map will become now 1 is to 1, and index of this equal to sum equal to this of 3 is to 1. Now coming to index 2, which is having the value equal to 3. So my sum will become previous sum plus current, so 3 plus 3, that is equal to 6, right? So again check 6 minus 6, sum minus k, that is equal to 0. This is acceptable, right? And so with prefix sum 0, have we seen before? Yes, prefix sum 0 we are having, and that count is 1. Okay, so now our count will become 0 plus 1, that is 1 in this case. And again I'm going to, so just here what happened, let me tell you again. So instead of checking all the I manually, we directly got that prefix of I equal to 0 exists once, right? So that correspond to the sum array. Which one? It is start from 0, so 1 comma 2 comma 3 actually. Okay, so now I'm going to update my map as well. My map 0 is to 1, 1 is to 1, 3 is to 1, and 6 sum is now appears once, right? Now let's move to index 3. What is the value of index? That is equal to 4. So my sum will become previous sum plus current element, that is 10, right? Then sum minus k, so 10 minus k is equal to 6, that is equal to 4. So it's not going to match. So what I'll do, I will going to update my map now. That will become, we got sum 10 is once came again, right? 0 is to 1, 1 is to 1, 3 sum comes once first time, and 6 also come once, and now 10 also comes once, right? Now coming to index 4, and value of index 4, that is equal to 5, correct? So my sum will become previous sum 10 plus 5, that is equal to 15, and 15 minus 6, that is coming how much? 9. which is not 6, right? So I'm going to update my map again. So this will become 0:1, 1:1, 3 comes 1, 6 comes 1, 10 comes 1, and 15 also comes 1, right? Let's do for the index 5 now. Sorry, I just okay, so index 5. So index 5 is what? Values equal to 6. So sum will become previous sum 15 plus 6, that is equal to 21, and sum minus k, that is coming 15. Okay, so you see here 15 is already present here, right, in the map. So, and count is that map of 15, that is equal to 1, correct? So my count will be increases. Count equal to count plus a previous count was 1, so 1 plus 1, that equal to 2 now, right? Now, and what will be the subarray for this? Now I'm left with 6, right? So in this way we have find the count equal to 2, right? So if you see the inner loop in the naive approach is completely removed by your hash map. What we were doing earlier, if you remember, for j equal to 5, we were checking for each I, means I equal to 0, 1, 2, 3, 4, and 5. Till 5 we checked. So now with this approach, we have to just check what? Map of 21 minus 6. If map 15. So if map 15 is present in that above array, okay, in scene hash map, then we are going to increment the count. So one operation instead of this 6 check, okay. So map stores all possible prefix I values seen so far. So instead of searching, we directly fetch the answer. And hash map is of course replacing the inner loop. So hope you understand that. So let me tell you the pseudocode for this now, how the pseudocode will run. So initially what we're having, sum equal to 0, that variable we have to initialize, count equal to 0, and map equal to 0 sum with 1 frequency, correct? So for all the numbers in your array, what I'm going to do, sum equal to previous sum plus this number, current number, right? And if your map contains your sum minus k, it means that sum is already visited. So you are going to increment the count. Count equal to count plus map sum minus k, correct? This is plus. Otherwise, just put first count, right? Because it is occurred, it is visited only one time, equal to 1, correct? So this is how, this code is we are going to write. So hope you understand this. So see, when you're doing the first time, maybe you are not understanding like why this approach came, but once you realize the picture, how the prefix sum work, you will get the point. Okay, just try it and let me know if you feel like okay, you are not able to understand. I will try some different approach. Okay, so let's see you in the next lecture with the Java program for this.